Rainbow is in the rare earth space, which I'm not too sure how many of you guys are aware of what's happening in the strategic mineral, but all the green technology going forward is dependent on some kind of rare earths, wind turbine, EVs, all the computers, all the modern tech, and also all the modern armaments that the US and the European sophisticated armaments industry uses. Basically, as I said, we've got huge technological process. Environmental change is also driving the demand of rare earths from the point of view that emissions are worrying the whole world at the moment, smog levels in the major cities around the world, and there's a massive drive to EVs, as we all know about. Rare earths are made out of 17 elements found on the periodic table. They're not rare as such, but they're rare in economic quantities, and they're also quite difficult to crack into the 17 different elements. By the way, there's a prize for everyone who can get all 17 after this presentation. So as I said, they're used across a range of uses, industrial uses, and especially in the green tech going forward. China dominates demand. They control about 85% of actual production and about 90% of the value chain. And this is concerning for the Western world at the moment in terms of the US and Europeans also worrying about the fact that all these strategic minerals come out of China at the moment. In Rainbow's basket, the two key metals at the moment are neodymium and praseodymium. These are used in permanent magnets, and permanent magnets are the key magnets that go into all the electric vehicles these days, all the wind turbines, and your cell phone, when it vibrates, it's a permanent magnet. Your earphones need permanent magnets. And it makes up about 20% of our basket, but it's 80% of the value in the rare earth basket at the moment. So we have quite a good mix of these two strategic metals in our basket. As I said, electric vehicles, wind, industrial motors, robots, all these things need these rare earth magnets. The big driver, though, is the demand for electric vehicles, which we see exploding over the next 10 years. Basically, if you have a look at the neodymium and praseodymium production in the world right now, there's about 40,000 tons total production. By 2025, electric vehicles will use all that production themselves, as well as need another 20,000 tons. And by 2030, we need 80,000 tons. And once again, that's all the current consumption plus another 40,000 tons just for the EV market alone. That excludes things like wind turbines. Wind turbines at the moment, for every megawatt, you need about 250 kilograms of rare earth elements. So a 3 megawatt wind turbine takes 650 kilograms of rare earth elements alone in the permanent magnets. And this is also a huge area for demand growth in the space. As I said, electric vehicles, the market's committing $300 billion over the next few years into EV production, and they're going to need these strategic minerals. Drones, another source. Military applications, very key. And I'm going to just go into Rainbow itself. And as I've mentioned, this is dominated by China at the moment. We've got the US coming into production, and then there's a few other countries around the world, not many of them. As I mentioned, the value chain, very dependent upon China, all the way from production right through until the actual magnet manufacturing. And the rest of the 10% that Chinese don't control is basically Japan, South Korea, and I think there's some in Estonia. As we said, the Chinese control supply and they control price. But eventually, they're becoming net importers of material, and they're going to battle to export, and we see there'll be a dramatic shift in price over the next year or two. Just to go into Rainbow now, Rainbow's got the only operating rare earth mine in Africa. We've got a project called Gakara in Burundi. Burundi is a landlocked country. People say, what about the political situation in Burundi? Well, just last week, the president, he's a young president, he's plus minus 50 years old. He announced he's not going to stand a third term. He's going to step down, and he's already appointed a successor, which is rare for Africa to have such a young president not try and stand till he's about 100 years old. Anyway, going back to, so Burundi at the moment, our logistics are very good. We're 25 minutes outside of the capital to our plant site. We're another 20 kilometers inland into the hills to where the actual mine is. And in terms of logistics in Africa, that's very, very good. We export our material on road through Mombasa and Dar es Salaam. And at the moment, we've been trial mining, what I call commercial trial mining, for the last 2 years. And that's basically about 2,000 tons of concentrate that we've produced and exported via our contract with ThyssenKrupp, our takeoff contract with ThyssenKrupp, and that goes into China at the moment. The one thing that Rainbow has got on its side is that it's a very, very high concentrate that we produce. It ranges between 52 and 58% grade, which is one of the highest grade concentrates in the world. Very importantly, our mineralogy is also very good. We produce this concentrate grade just with, we free dig, so very low mining costs. We crush it, we have a bit of a DMS and some shaking tables with water, and we get our concentrate. And no matter where we've mined within the concession, we get the same mineralogy dropping out, and very importantly, very low levels of uranium and thorium. Our uranium levels are about 14 ppm in uranium and 28 ppm in thorium. Now, the microwave in your kitchen's got more radioactivity than our material has, so it's very, very green. We don't use any reagents, very, very green production source for funds that are looking for a green angle. To go back into our deposit, this, as I said, they've been trial mining. I took over about 4 months ago, 5 months ago. I've changed things quite dramatically in country, went in and cut costs quite dramatically, and I'm embarked on a proper exploration program to give us a JORC resource. We expect JORC resource to be signed off by CSA Global. They signed off on Linus's resource by the end of March, and we're looking at our first target, 10,000 tons per annum of production for minimum of a 10-year life of mine. Our first resource is coming from Kienzi, which is the first target. As you can see from this map, we've got over 1,000 occurrences of rare earth. We've got 30 exploration targets. Each one of these targets is mineralized, and that gives me a lot of confidence that we're in a big system, which I know we're in a big system, and I'm busy proving that. Very importantly, we've got 7 historical mines within our concession, our mining concession. And mining in Africa over the last 30 years, probably 9 out of 10 modern mines have been built on old historical mines. So the fact that we've got 7 bodes very well for the fact that we're into a very big system here. And as I said, that Kienzi target, we'll expand it by August in terms of life of mine as well as in terms of size of the resource. That's our mineralization, as I said, comes from a single source. It's carbonatite. And we've got 2 types of host mineralization in our area. We've got a breccia type pipe, which is Kienzi, and we've got this vein mineralization. The Belgians were mining the main mineralizations in the 40s, 50s, 60s, and 70s when they left the country. And these veins are very, very high grade. The in situ grade in the veins is running at about 58 to 68% TREO, which is the highest in the world. But we can't mine these veins surgically. We've got to bulk mine them, and that's my next stage is to build a proper resource model for those main vein deposits, so we can get them into a resource as well. As I've mentioned, our product is very clean. Typical ton of rare earth at the moment produces lots of contamination and lots of radioactivity. We don't have any of those problems, which also bodes very well for us going forward. As I've mentioned, I've got 3 stages. One is to get up to 10,000 tons per annum of production, and for a minimum of 10 years, that's my JORC resource. And then my next target, I'm going to double this. Because of the way the resource is within our property, I can do this on a modular basis, and to do the next 10,000 tons will be very easy. I've built 22 mines throughout Africa, and I've done over 100 feasibility studies with my previous business, which I listed and sold to Hammack Foster Wheeler. So I've been through this process with lots of clients, and now I'm on the other side. And I think my targets are very real in terms of timing and what I aim to achieve. After I've got up to 10,000 tons per annum of production of concentrate, my next stage is to do the first stage of beneficiation. I need to do this to turn this into a real business, and that is basically on 10,000 tons per annum, I've only got $17 million of turnover because we get a big discount to the rare earth basket in terms of our concentrate. But just taking it up to a rare earth carbonate or rare earth oxide, that discount narrows between 10 and 20%, and my revenue goes up to about $50 million. At a 40% EBITDA, I'm starting to get a real business. And then if I double that, to 20,000 tons per annum of production, my numbers start looking quite good. The capex to do that next stage is also, SGS in Canada have done a scoping study, and basically it's, if you can work out the numbers for yourself, this is on our website, it makes sense to do this next stage of beneficiation. Just potential financing options, funds driven by the ESG mantra, auto companies. We saw JOGMEC made an investment in a rare earth project in Namibia, which is a long, long way from being developed, and potentially governments as well. As I said, I can get into 10,000 tons of production from my current small-scale production in 2 years, which is the one advantage I've got as well. And that's in summary. Thanks very much, gentlemen and ladies.